Then, shall we? So thank you everybody for joining me. Good morning, good afternoon, or good evening, wherever you may be in the world. We do have a code of conduct, which I've included in my deck, which is nice to see these days in conferences. But yes, a complete introduction to Azure Data Factory. Now, the thing I want to start with is actually just by scrutinizing my own title here, because I've done this very deliberately actually, and depending on how pedantic you want to be, we could say, well, an introduction to Data Factory, complete Data Factory. You know, an introduction are very much a conflict in terms, if you like. And that really is kind of to challenge myself a little actually in this title as well, because there is now so much that goes into Azure Data Factory, as I'm hopefully going to show you in this session, that actually when it comes to doing an introduction of it, that is hard for me, because it's hard to know what to exclude from this content, and doing an introduction session, believe me, is actually harder than doing a level 400 sort of in-depth thing on Data Factory on any part of it. So bit of fun with the title there, but you know, hopefully this will become clear. I can promise you that everything listed in my abstract I've covered, and then some more things as well. But if you feel that there's something there that I haven't covered in this introduction, then, you know, reach out to me on Twitter or on the Slack channel. I've got the chat open as well, so we'll look out for the Q&A. We'll see how we get on. As Alexander has kindly said, yes, my name is Paul Andrew. I'm a principal consultant and an architect over in the UK. My Twitter and LinkedIn and blog details and things there at the bottom, all Mr. Paul Andrew. Everything that I tend to work with is Mr. Paul Andrew, so get in touch. The first slide I will put up is this one. If you want to actually take a copy of my slide deck, you are very welcome to it. It is already up in my GitHub repository. There's one there called Community Events and a subfolder for the events that I've spoken at. So in this case, there's a subfolder there for GroupBy. It's got a PDF of these slides. It's actually also got an ARM template of my demo Data Factory that I'll show you. Good, so do feel free to go and grab that. Then let's take a look at our agenda, the thing that I've already kind of told you that I struggle with here when it comes to an introduction. So, you know, what to exclude at this point. So what I'm going to go through is the obvious, the what and the why, the components we need, my favorite activities within a data factory, our execution dependencies, which is a common problem that I see go wrong. What are our integration runtimes? SSIS packages, actually getting them running in Azure, because I know there's a lot of investment still out there in SIS packages. Then we'll sort of change gears a little bit and look at data flows. And then the last three things we'll kind of look at what I would call more sort of data factory in production, the source code, deploying it, monitoring, logging, and then kind of wrap up with some conclusions. So hopefully that's what we're going to cover. And as I say, it's hard to know what to exclude from an introduction, but we'll see how we get on. So first up, Data Factory, the what and the why. What is it? Why use it? And to kind of sort of set the scene here, what I want to do is give you a quick history lesson, if you like. So Data Factory as a service and within Microsoft Azure, it's actually been around now, which still surprises me, since about July 2016. So back in the sort of middle of 2016, I was playing with the private preview of this service, the first ever Data Factory that we saw, which was version 1. And you know, it was okay. You know, it kind of served a purpose for our other Azure resources that we had at the time. But you know, there was obviously a lot of gaps, and these things, they mature, of course, with time. And I think it's fairly safe to say, as you can see from my timeline, that Data Factory now, in the last sort of 4 years or so, has matured a lot. The breadth of what the service can do and the depth of what the service can do, it's come on massively. And yeah, I've kind of put a few things on that timeline there. Source control, probably an obvious one. Data flows was actually only first introduced. I saw the alpha version of data flows over in Redmond in March 2018. So, you know, there's parts of the service that are still perhaps quite new. some parts of it that are very mature, but you know, as a complete Azure resource now, it's definitely come on leaps and bounds. So quick timeline, quick history lesson. If we though do ask the question of what is Data Factory, and I always kind of start by referring to the Microsoft slide. And this is what we get if we go to the Microsoft website. And I look at this website a lot, and it does change a lot. Today's version of what Microsoft say Data Factory is obviously looks more like a steam train now that we have going along choo-choo, which is the only 3D graphic of Data Factory I've ever seen, which is fun. But the kind of takeaways we've got here are what the marketing people tell us is integration. We can safely say that Data Factory, given this website, has something to do with integration and data, of course. So that's fine. Data Factory is apparently this hybrid data integration service that simplifies our ETL at scale. Sure, okay, we can go with that. That's the Microsoft version. Of course, I want to go into a lot more detail. So the way I want to describe it for you guys is to give it some context. I want to say that we have some data process or some data or something that we need to do. So here I've got some files that I want to copy. I want to transform them. I want to put them in storage or maybe a relational database. You know, hopefully a fairly common pattern of getting something from A to B to C. So if we then say, well, what is Data Factory? And what I can do is I can say that Data Factory in this context is the orchestrator of that process. And you'll see my little conductor man over there on the left-hand side, if we can kind of go with that metaphor for now. So Data Factory in this context, it's the umbrella, the orchestrator of this thing that we want to happen, getting that data from left to right, basically. So let's leave it at that for now. I'm going to say it's the orchestrator, and then we can go into more depth as we go through. And the first thing to start with is to say, okay, well, if Data Factory is going to be the orchestrator of that process, what is it that I actually need to build within my Data Factory to make that happen? So if we come back to that same process and we just kind of park it at the top there for the moment, we actually look at the components that go into that Data Factory. The first thing you will actually need to build or create is something called a link service. And a link service for Data Factory is the mechanism that it actually needs to connect, authenticate, and interact with those other services that we have out there. You know, it could be a SQL database, it could be a Databricks instance, it could be a whole load of things. I think Data Factory now, it's got over 100 different link service connections that you can create to all sorts of weird and wonderful things. But it is that means of what is it I'm going to talk to, where is it, how do I authenticate? So if we said we're talking to a SQL database, we could provide the host name for that instance, the database information, the username, the password perhaps could go into a link service connection. And if you are an SSIS person, we could make the comparison between a Data Factory link service and what we had within our SIS packages as the service connection manager. Similar idea. So that's number one, our link service connections that we need within our Data Factory. Next up is number two. Number two is this thing called a data set. So not the actual data, but just more of a metadata representation of what it is Data Factory needs to know to work with whatever we're going to be using. So we could say, in the case of a SQL database, the schema, the table name, you know, the data type, the structure of that table, things about that data set that we're going to work with. As another example here, as you can see on my slide, if it's a file within our storage, we'll have the file path defined there, the data, the file format. So everything about that data that we want to work with will be defined in our Data Factory as a data set. And data sets will authenticate using our link services in number one. Next up, we have number three, this thing called an activity. So in my hypothetical process that I've got there at the top where we want something to happen, the activity is that piece of information that is specific to the work that we want Data Factory to go and do. So if we said we're going to hit a Databricks notebook, we would have an activity specifically for that. And it would have information in that activity about the Databricks instance that we're going to hit, the workspace, the notebook name that we're going to call, any parameters that we want to pass to it. So say information specific to the service we want to go and invoke, the thing we want to execute, basically. And there's a lot of different activities, as we'll see as we go through this session. So that's number 3. And like with our data sets, our activities can authenticate with our link services, number 1. Next up is this idea of a pipeline. Now, we could absolutely say that everything that I've got there is a data pipeline. And sure, in that context and using that terminology, fine. But also be aware that a pipeline is an important component of our data factory. And what a pipeline allows us to do is to basically logically group our activities together. One activity or many activities, it doesn't really matter. We put those pipelines around those things that we want to happen. And it's that pipeline that we then use to interact with our data factory. And more comparisons perhaps with SSIS, we could say that a pipeline is like our SSIS sequence container. Sure, it's a reasonable comparison. A better comparison, though, would be to say that a pipeline is actually like our SIS package itself. A package can call, of course, another package with an action or a task. And the same is true with Data Factory. We can have an activity within a pipeline that calls another pipeline, and we can then sort of nest them and create that generational set of pipelines, as I'll talk about a bit later. So those are our pipelines. And as for completeness, as I've said, a pipeline could contain one or many activities. It doesn't really matter, but it's that pipeline that we're going to use within our Data Factory to build and interact with our services. Then lastly, number 5 is a thing called a trigger. So we need to trigger our pipelines to execute. So we attach triggers to our pipelines. It could be one trigger for many pipelines, or a one-to-one, or some other setup that you might find useful. And those triggers can take a few different forms. We can, of course, trigger our pipelines manually if we want to, via the Data Factory UI, sure. We can do it programmatically via the .NET SDK, via a bit of PowerShell, via the REST API, however you want, really. There's lots of options to tell that pipeline to go and run if you want to call it from something else. A scheduled trigger is perhaps the most common, and we can perhaps think of a scheduled trigger a little bit like our SQL Server Agent. We can have that very recursive happen at a particular point every day, every week, whatever, and that will just keep going until a particular end. A tumbling window trigger is actually something that was inherited from Data Factory v1, where it was called time slicers. And what time slicers or tumbling window triggers allow you to do is to define a timeline and carve that timeline up into particular sections. So daily, weekly, monthly, whatever. And then for your time series data, you can say that a time slice or a window within that tumble is one execution of your pipeline. And you can allow that to happen every time. That timeline is a fixed period. You will need to extend it if you want to go forward. So don't confuse it with our schedule, our recursive thing. Think of that timeline and then that one pipeline execution within it. And as I say, that's inherited from Data Factory v1 as well, but it can be useful for time series data, particularly accounting and finance might be my preferred way of triggering our pipelines. And then lastly, a file-based event we can subscribe to. So when, for example, a file gets created or deleted in our blob storage account, we can subscribe to that event that can then trigger our Data Factory pipeline. So that's another option we have. So those are our 5 triggers or 5 options for triggering our pipelines. And those triggers, as I say, they will attach to a pipeline. And those are the 5 components that we have within our data factory. And as you've probably gathered from my slides, those are all created using JSON underneath. And we can say that those 5 components for our data factory as the orchestrator, the umbrella, the conductor, those are the 5 components that we actually need within our data factory to perhaps build and to make this data engineering process happen. And what we can do is maybe some title maintenance as well. We can say that those are the control flow components of our data factory, and absolutely drawing comparisons again to our SIS packages. In our SIS package, we had that control flow plane and we had that data flow transformation set, which we will talk about later. For now, I'm going to say those are the 5 components of our data factory control flow that is going to orchestrate this data engineering process, let's say. So given that then, and hopefully kind of alluding a little bit to the what and certainly the why we might want to use data factory to make this thing happen, let's go a little deeper. Let's go a little deeper and look at some common activities. And what I've done is, because everything should be represented as a SQL query in my mind, I'm going to say let's select the top 5 of Paul's favorite activities. So really sort of focusing now on number 3. What is it that we're actually going to do, and what are we going to maybe put together in our pipelines? What are those common activities that I like to use? The first one, perhaps fairly obviously, is the copy activity. We want to get a data set, we want to copy it from left to right. Just be careful, this is not a move operation, this is absolutely a copy. And that copy activity now will support that. It will talk to and use all of our linked service connections. We can define data sets of all sorts of weird and wonderful types. And as expected, we copy that data from left to right. The copy activity does now in its maturity have some very nice features that we can use as well. Auto scaling is definitely a favorite. So it will increase the underlying compute when we've got lots of data that we need to copy. Transactional restarts are definitely an attractive one. If you've got a lot of data that you need to get somewhere, it will handle that restartability if you've got, say, a network interruption or something like that. Handling compression is a nice one. So if you have a zip file, you can unzip it as part of the copy. And a few others there as well that I won't go through the bullet points, but you get the idea. The copy is definitely a favorite, definitely one that I'll probably include in a lot of my data factories just to get that data from A to B. Next up, we have the lookup activity. Now, I don't want to confuse this as a data transformation thing at this point. We are looking up from a data set, and really we're looking up some metadata, something that's going to help us within our control flow pipeline. And what we could say as an example, I'm going to look up some contents from a SQL database table. I'm going to give it a select statement. And what that lookup will do is query the table and it will return the values of that lookup. And as you can see on the right-hand side there, the result is some JSON. We have a value array, which is basically the content of that select statement of that table that's been queried from that database. And I've deliberately labeled this like that. So this is something that I'm going to show you in my demos as well a bit later on. So a lookup activity used to get metadata within our control flow pipeline. Do be mindful as well that a lookup, it's not intended really at this point to get lots of data. There are some limitations of the lookup, which is why I've put the link there at the bottom to the Microsoft Docs. Currently, I think 2 megabytes of data or 5,000 rows of data can be returned from a lookup. Whether it's a SQL table or whether it's hitting a CSV or a JSON data set itself, whatever, just bear that in mind. Next up is my maybe number one favorite. Don't tell them, yeah, they're all my favorites. And that is the for each activity. And what I've kind of put here in the subtitle, as you'll see, is scaling out our control flow activities. Well, what do I mean by that? Well, our for each activity will accept an array of values. Probably nothing surprising there about a for each, which, probably fairly naturally is going to be supplied by a lookup, given what I've just told you about a lookup activity. And then, of course, the for each will iterate over that content, and you'll have some activities within that for each that could be a copy, or could be whatever. And you can use that item iterator within the for each to do whatever you need to do. Fine. But that doesn't still address this scaling out thing. And that's because the for each activity within Data Factory has some quite special behavior. And that is that it doesn't, by default, execute those iterations going over those items sequentially. It can do, and that's perhaps what we would expect from a for each. But actually, within Data Factory, its default behavior is to run all of those threads in parallel. So that array we provide, however many items are in that array, it will scale out and it will run them at the same time. And by default, the batch count for doing that will be 20 parallel threads. It can go all the way up to 50 parallel threads if you like. So that's why I think for each is perhaps a definite favorite of mine, because with very little effort, you can straight away, design for parallelism, actually get that parallelism from the for each activity. So if I had 20 files to copy from an on-premises file server, I could copy them all at once just by nesting that copy within a for each. So bear that in mind as a definite advantage and definite design pattern when you're working within Data Factory. Moving on, we have, as I've already alluded to, the execute pipeline activity. And the reason for me kind of including this in my favorites is just for that ability to nest our pipelines, to have what I will call, and what I've linked there with my blog, a generational set of pipelines, a hierarchy of pipelines. And I'm not claiming to have reinvented the wheel here. Very much back in the days of SSIS packages, of course, we would have one package calling another, and a framework of packages. Absolutely the same thing can be achieved here with Data Factory pipelines as well. So that activity there is included in the favorites, just for that capability of how we actually structure and how we design our Data Factory pipelines. Then lastly, I think, I can't count to 5 sadly, is a Azure function activity. Now, this is a relatively new activity that we now get within our Data Factory. Originally, we would, if we wanted to hit something, perhaps we could use the web and the webhook activities within our Data Factory. But what Microsoft have done is they've now made our Azure functions first-class citizens within our Data Factory, which means we can hit a function, with our usual sort of REST methods, get, post, puts, delete, whatever, and we can pass in some body information to that function. That function can perhaps contain, in my case anyway, some C# that's been created in .NET Core. That's what I would do, but Python and other options certainly available. And we can then ask that function to go and do whatever. As an example, I might have an Azure function in there which creates and deletes partitions in an analysis services instance. We don't have a native activity in Data Factory to do that, so we could do that with an Azure function if you want. Maybe we use a function to stop and start our a SQL data warehouse, or scale something up or down. It's just that ability really at this point to extend our Data Factory with REST calls, as my subheading suggests. So those are my 5 activities, my 5 favorites, if you like. And I come back to here of, what do I exclude? What are my favorites? And those are the ones I've picked for you today. So next then, let's think about our pipeline, and let's actually think about how we're going to structure those activities within it. And I'm going to call this out as execution dependencies, just because I see it go wrong more often than not, actually. So if we had a pipeline and we have an Azure function activity, we can then, downstream of that, have dependencies for success, fail, complete, and skip. So we can connect our activities together within our pipeline, and of course, depending on the result, things will happen. So let's say, hypothetically, we have a pipeline where we get some values with an Azure function, and we have another child pipeline that is a failure handler, an error handler. So after that gets values fails or errors, it's going to then call that child pipeline. Fine. Let's say we have another activity in here where we do stuff. I'm very descriptive here. We're just doing stuff with a Databricks notebook. So I've got a Databricks activity. After my function succeeds, I'm going to run my Databricks notebook. Sure. And of course, from that functions activity, we're actually saying that on failure, use my error handler, on success, call my Databricks notebook. Fine. We could, though, of course, think, well, I want my failure handler pipeline to be used for my Databricks notebook as well. Sure. So we connect things up. And maybe we then go further and we say, actually, I'm going to have a store procedure after this that's going to run as well. And I'm going to connect that to my failure handler. But as you can already see, I've already kind of got a big red cross on this slide, because that isn't going to work. We aren't going to get that failure handler child pipeline called in the way that we perhaps think. And the reason for that is that if we do a logic test here, what we're actually saying is that we need these things to fail, and that thing to fail, and that thing to fail, which of course, as you know from the creation of this pipeline, that's not going to work. So just be mindful that if you've got that error handler path or that failure path, then this failure handler pipeline that I've put in here, it's not going to get called, because of course we're never going to have a situation whereby one activity succeeds and the other ones fail as well. It's that and that you just need to be careful of. So of course we do need to just refactor our pipeline. We need to bring in some other activities here, and the correct way to create that is by having multiple activities. And when of course we do that, it's not an and operation, it's an or. So if this fails, or that fails, or that fails, go to that error handler. So just bear that in mind. It's probably an obvious thing, but I see it happen so many times that somebody has an error logger or something like that, and they always call it using that and logic rather than the or logic, and then they wonder why they never get any failures alerted. So just bear that in mind. Next up then, let's think about these things called integration runtimes. So in the beginning, we talked about these 5 components of our data factory, and we had 5 of my favorite activities. I've done things in 5s here in this talk, it seems. So next up, let's think about an integration runtime. Oh, left off an animation there, not to worry. So what is an integration runtime then? Because we've talked about Data Factory as an orchestrator. And what I want to do is go a little deeper now and actually say, well, Data Factory as a resource, yes, we can think of it as an orchestrator, but to better answer this question, we can think of it as 2 services. We can think of it as the orchestrator, the little man conducting there, as I've kind of alluded to, but we can also think of it as the runtime compute as well. In its very sort of generic form here. So Data Factory is not just one service potentially, it's two. It's the orchestrator and it's the compute. And of course, we need both for things to happen. And the way to kind of expand on that and think about them more is to say that our orchestrator is fixed to a particular Azure region, and our compute can actually be region flexible. So why? Why is that helpful? Well, if we look to the right on this slide now, and what I could say to you is that because we're now talking about Data Factory as not just one service, but in theory two under the hood, we could, if we wanted to, have that orchestrator sat there in some Azure region. But then we can define our compute, our integration runtime, as being applicable in the region. Now, out of the box, within your Data Factory, as I'll show you, you get one of these integration runtimes. You have to have at least one because Data Factory does need that compute to do anything. But it does mean that that one bit of compute you get out of the box, it will auto-resolve to the region that it feels is applicable for whatever you're doing. But of course, you can control it. So just kind of bear this pattern in mind for now. So that's what an integration runtime is. But now to go deeper again, what I'm going to say to you is that there are actually three types of these integration runtimes that we could build and we could use within our Data Factory. The Azure integration runtime, a hosted integration runtime, and an SSIS integration runtime. Now, perhaps the last one is fairly obvious what it does, but the first two, let's just elaborate then. And let's now pose the question of, okay, well, what can an integration runtime do? How is it going to help me within my Data Factory? So let's start with number one, the Azure IR. And what I'm going to do is I'm going to come back to this picture, and to tidy things up and to be precise about it, let's just replace those icons and say, okay, I have an Azure integration runtime that exists within my Data Factory by default. When I deploy my Data Factory, I'm going to get one of these, and it is going to auto resolve to a particular region that it feels is applicable. So say, well, okay, well, what else is it going to do for me? How is it going to help me? And the way to think about it actually is if we sort of dive maybe into one of those pipelines, and we now introduce this notion of our activities that could be internal and external activities. So bear with me. And what we can say is that an internal activity could be something like a wait operation, an if condition, or maybe a delete operation. And that is what we could give an example as an internal activity. External activities, I've listed here as examples, could be hitting an Azure function, hitting a Databricks notebook, and hitting a SQL database. And you think, okay, well, what's the point here? The point is that for our Azure integration runtime, the thing that we get out of the box within our Data Factory, it is the compute responsible for those internal activities. Okay, so that's the way to sort of differentiate them. And hopefully, given those examples, it kind of makes sense the fact that the compute for an Azure function is the underlying app service plan. The compute for a Databricks notebook is, of course, the Databricks cluster. So Data Factory is not responsible for that compute. It just has an activity to reference it. The Azure IR is responsible for the compute for those internal activities, those things that it's responsible for doing at that control flow level. Okay, hopefully that makes sense. Next up then, let's turn our attention to our hosted integration runtime, something that was renamed from ADF v1 as the Data Management Gateway. And hopefully maybe that title is perhaps a little more informative, but we'll stick with the hosted IR name for now. And what we can say is that on the right-hand side there now, within our Azure environment, we have our data factory and we have our Azure IR, we have our orchestrator, what we can do is we can then actually go the other way. And we can say, well, if I have some on-premises resources that I want to interact with, I can deploy some compute down there. I can deploy this hosted IR down there where my local things exist. And that means then that our conductor that was kind of focused that way, we can flip him round and we can focus him the other way as well. And we can say that Data Factory can now reach down to our on-premises databases, ODBC connections if we wish, our file server, things like that. And our orchestrator can actually now use that hosted integration runtime as the compute, as the client that sits there on our local network to get those things as well. And what we can also do is with that hosted integration runtime, we don't just have to have one of them, we can have many of them. So we can have many nodes, or sorry, not many, we can have 4 nodes per hosted integration runtime endpoint. And they can operate in a failover and load balanced type relationship. So we could, if we wish, have one data factory, many hosted integration runtime nodes. We can also go the other way. We can have one hosted integration runtime node talking and used by many data factories. And that was the reason for that difference in the icon, that if we have a second data factory using that same hosted integration runtime, it gets referred to as a linked integration runtime. It's linked from that primary data factory. Okay, so there's obviously quite a lot that I've been through there in terms of theory and slides. What I want to do is let's break into a demo and actually kind of bring some of this stuff to life, because we don't want death by PowerPoint. So let me just bring some things up here so I can share this screen with you. And then what I've got here is my training data factory. And what I want to do is I want to just get some data from my laptop in this case. Now, my laptop has a hosted integration runtime installed on it. It apparently needs an update, which I didn't do deliberately because it currently works. I'm sure if I updated it before my talk, it wouldn't work. Those are the rules. So this hosted integration runtime is an executable. It's a client installed on my laptop, and I want to be able to use it to upload some files. So what I've got on my laptop is, let's bring this down here. On my C drive, I have a folder that I've called ADF root, and I have some subfolders of some very demo-friendly CSVs that I want to get into Azure. This is my scenario. So I have this hosted IR already installed, and I have this data factory. But this hosted IR is actually registered to a different data factory. It's not registered to the training factory that I'm showing you here. And that's because it's linked. So I've done the work here to reference it already. And just to kind of sort of show you that relationship, also as a total side note, in your browser, I tend to go to adf.azure.com. I don't go via the Azure portal every time. I get bored of clicking around that. So adf.azure.com is definitely my favorite URL. And as you'll see, that'll give you your tenants available. It'll give you your subscriptions available. And I want to go to Paul's Fun Factory, where all the fun begins. And what I've done is, because in my Fun Factory, which is kind of what I use for all my demos and messing around and things, I've got in here, in my sort of management toolbox, I have an integration runtime for my laptop. And what I can do is I can go to the sharing tab and I can copy the resource ID. And then what you can see is I can grant permissions to other data factories that it finds within my environment. And I've already done that. So my training data factory has been granted permissions to my laptop hosted IR. So definitely a nice thing to do if you've got lots of data factories all sharing that local compute. So I've got that set up. So let me just show you in this other data factory, in the integration runtimes, Paul's laptop, hosted IR, subtype, linked. And then what I can do is I can then build a pipeline, or I can use a pipeline I've already built. Now, if I want to get that data from my laptop, I want to get it up into Azure. Can you share an IR across tenants? The IR doesn't really understand tenants in that sense. Good question. No, I think is the answer. An IR cannot work across tenants. It needs that resource ID within the tenant where the other data factory is. Good question, thanks. Anyway, sorry. Maybe I'll close that. I'm going to get distracted by the chat window. So I want to upload some data. And the first way I'm perhaps going to do that, the simplest way, is just to bring in a copy activity. And I can then, in the source of that copy, I can define a data set, which perhaps in this case is going to be a data set to my people table and to my person CSV file. So that's what I've got here, a data set just representing that CSV. And if I look at the internals of that data set, you can see that it's got that file path to my C drive, to that directory I just showed you. And that is coming from a link service, which is using my Paul's laptop hosted integration runtime. So I've got those bits and pieces plumbed in, those first three components, if you like, that I showed you in my slides. So the link service, the data set, I've got a pipeline, and I've got a copy activity. So that's a very, very simple source, and that's only going to deal with one CSV file. And then I've got another data set to land that CSV file, this time into a data lake storage account, into a container that I've called data warehouse and a folder that I've called landing, and I've hard coded the file name in there as well. So with that, I can, sorry if you heard my Ring doorbell over the microphone there. So I've got that storage account in Azure, and I can now run my pipeline in debug mode. We'll talk a little bit more about debug mode and triggering our pipelines and that sort of relationship a bit later. But for now, I'm just going to run this in debug mode. It's going to upload that CSV file for me. He says, successful. And I can come back in here, hit refresh, person file uploaded. So really, really simple, just a one-to-one file copy. But you know, of course, we don't want to really go that simplistic in the real world. So that's kind of sort of example number one. Example number two, or upload pipeline number two, just to kind of show you how we can make things a little bit more interesting. I've got another copy activity, but this time in my source, what I've done is I've made the data set a little more dynamic. It still is looking at my C drive, but now what I've done is for the directory and the file name, I've put those in as parameters. So I can add parameters to the parts of my data factory. So a parameter here for the directory for the file. And what happens is when I add those parameters, they get bubbled up in my pipeline, in my copy activity. And I've now just kind of put those values in at this level instead. Excuse me. And I've done the same thing with a data set in my data lake, parameters and the directory passed in. So in theory, what I could now do is that all those files that I've got on premises, I could actually upload any of them now by overriding these pipeline parameters that have been surfaced, sorry, these data set parameters that have been surfaced here. I won't run that, but that's just an idea of how you can sort of extend this. I'm going to extend it then one more as well. So more sort of alluding to what's perhaps a more common pattern or something that we might do. What I've done this time is, because as you obviously saw from my local directory, I've got a few different things in here, not just one, I've got a few files. So this time I'm using a metadata activity. And the data set for that metadata activity is just going to look at the people directory that's been parameterized, that data set on my local machine. And what I can do is I can get that metadata, which I've actually already ran once in debug mode, and that is going to return an array inspecting the contents of that folder that I've got and list those 4 files that are in there. Then I can break out my friend the for each activity. I can give it that array of data sets that have been found from the metadata activity. I can use that as the array to then iterate over, and within my for each, I then use the copy. The copy this time is using those data sets that can be parameterized, but of course, instead of hard coding them, I'm going to use that item iterator that's been provided from my metadata activity. So really just a very simple inspect, or as I've said, kind of get a list of files from my local machine. What are they called? And then dynamically drive a copy activity within a for each, which, as you'll see, is parallelized 4 times because there's 4 items in that array. So it's going to copy all of them this time up into my storage, which, you know, is definitely a nicer pattern. All good, all successful. So if I just come back to my data warehouse, 4 files now uploaded. Okay, so that was number 3. I want to go one more, number 4. I know it's an introduction, but I think it's worth kind of exploring these different patterns. So same idea, but of course you'll have noticed in my local storage, I've got a few subfolders. I've not just got the people folder, of course, which is what the pipeline number 3 did. I've got a few subfolders. So what I can do instead now with this one, I can now use some metadata to drive it, and absolutely using the lookup activity and the thing that I alluded to in my slides, I've got a files for upload table in a SQL database. And I can say in here, what's the source directory and what's the target directory and what's the file name. So I can then use that metadata from my SQL database. I can use a lookup activity to get it, which I'm just going to put a breakpoint on and run it in debug mode. I can then go through the same steps. I froze for a moment there. I can then go through the same steps. I can then return that array, that value array of the things that I want to use. And then in my pipeline, within my for each activity, I can use that array, and then I can dynamically drive that copy activity. Oops, go away. I can drive that copy activity, this time passing in both the source directory and the file name, and upload that data to Azure. So that's just another example. I won't run that one, but those are kind of 4 pipelines that sort of really push and explain some of the stuff that I've talked about so far as an example. As I perhaps mentioned at the start, there is already an ARM template for this demo data factory in my GitHub repository as well. So go and have a look at the JSON for these pipelines if you wish. Okay, let's just turn this off and come back to the slides. He says, presenter mode loves to take over my entire desktop. So that was a quick demo and just a few pipelines to sort of cover the things I talked about so far, hopefully kind of converting that theory into practice. Now let's focus on that 3rd integration runtime. So we have an SSIS integration runtime, as I kind of alluded to. And okay, you know, what's this about then? And as I promised in my abstract, we want to look at how we run an SSIS package in Azure. So we need this compute. We need this integration runtime that we deploy within our data factory if we want to do this in a PaaS environment. You could, of course, run your sys packages on a Azure VM if you like, but doing it with only PaaS tech, we need Data Factory to get that. When we deploy it, we specify our perhaps usual things like the SQL instance where our SSIS catalog and that information is going to live. We can specify some file storage as well if we want to store our packages in there. So we have to give our data factory and that SSIS IR that information. Once we've done that though, we can absolutely create a pipeline. We can use a run package activity, and we can specify a package that we want to execute. So that's what we can do within our data factory to run our sys packages in its very simple form. But there's a problem, and a problem again that's kind of come from some experience, some battle scars that I want to allude to and just want to make you aware of. And that problem, as I'm going to describe it, is using all of the SSIS IR compute. So that integration runtime compute we've got deployed within our data factory, what actually goes into that is when you deploy it, it asks you to define the number of nodes that you want. You can have up to 10 nodes, which are basically SQL Server virtual machines underneath. You can, specify 8 packages running per node. So hopefully, as you can appreciate, that the SSIS IR does, in theory, support running 80 sys packages concurrently. Or we could say a max stop of 80, crudely. But my pipeline down there, of course, will only run one package, one pipeline, one activity, one package. So, hopefully that kind of problem kind of makes sense. And the reason for alluding to this is that people, of course, want to lift and shift their sys packages into Azure. There's a lot of investment gone into that, fine. But what people have perhaps done is they might have created a framework of sys packages, and they might have a parent package calling 80 odd child packages, if you like. Now, in that scenario, that's still not going to use all of that SSIS IR compute. That's not going to scale out across those nodes in the way that you want it to. That parent package is still only going to get an 80th of that compute. So that pattern isn't going to work. That parent package calling child packages is not going to make use of all of that, all of those IR nodes you've got available. So just bear that in mind. You might think, well, I could have one pipeline with 80 activities all in there and then referencing all of my packages to use all of that. Yes, that makes sense in theory, but Microsoft actually limits the number of activities you can have per pipeline. That limit is 40 activities. So that pattern isn't going to work either. And you might think, well, okay, I'm going to use your favorite activity, Paul. I'm going to use the for each activity. Okay, fine. But bear in mind that when you do that, that's only going to parallelize 50 packages. So you're still not going to make use of all of that 80. The actual solution to this, there's a few different ways you can go about it. And this is kind of one of those things that I was really conflicted about cutting out of the introduction session. The solutions to this, there's a few different ways around it. For the introduction, I just want you to be aware of that problem. So if you lift and shift those sys packages up into Azure using your data factory, just be mindful that you could encounter this limitation, or make sure you use all of that compute. You don't have to use 10 nodes within your SSIS IR. You could just use one big one, but bear it in mind as a problem and something to think about in your design. Next up then, and kind of hopefully leading nicely on from our SIS packages, because our SIS packages we can perhaps think about as the transformation work, the data flow work. What I want to hopefully now sort of segue into is Data Factory data flows. Now, I'll come back to this slide, and in this slide I said, yes, these are our control flow components. Well, what I'd now like to introduce you to is, if we do some title maintenance, a data flow, or the data flow components we have within our Data Factory. And these take two forms, which are currently called mapping and wrangling data flows. And these are represented as activities within our Data Factory. Excuse me. Now, we have our pipeline and we have our control flow plane. And we could, in theory, bring on our data flow activity and we define it. But what is that mapping data flow? What actually goes into that? And to add that data flow plane to this slide, this is what you'll get, or something like this. You will have that data flow, that graphical interface to perform that row level transformation on your data. And that's really what, in essence, a data flow is going to do here. We could very crudely say our mapping data flows within our Data Factory are very similar to the sort of developer environment that we got within our SIS packages. Now, what will happen is, or kind of where the differences are, is that within our Data Factory, that data flow that we define, that gets converted into what Microsoft called data flow script. We can dynamically generate that data flow script if we wish, but that's the output of that visual, that graphical data flow, this data flow script. Now, what then happens actually within Azure and within our Data Factory, that data flow script will be converted and recompiled as Scala. Once that happens, it'll be passed to Databricks or passed to Spark to execute. Now, of course, Spark is this sort of whole monster in itself, this complete analytics ecosystem of distributed compute for doing all sorts of weird and wonderful things. But that data flow, that visual that we've built within our Data Factory, it's going to be passed to Spark and execute using that distributed compute and that that capability that Spark has. So if we come back to my question of, well, what is a mapping data flow? Sure, we understand it as a transformation tool, but what we could do is perhaps as an answer to that is say, well, it is a graphical data transformation tool that sits as an abstraction over Spark in this case. So that's a really powerful thing, that suddenly we now have that scale out capability of Spark when we're doing our data transformations. As for the transformations themselves, these are currently the things that you can use to build up your pipeline or to build up your work you need. You'll notice that the lookup is listed there again. This is now perhaps the lookup that we are more familiar with, the lookup of getting a surrogate key for our fact data set or something when we're loading a data warehouse. So this is the lookup joining transform, not the lookup at a control flow level where we were getting metadata. So those are currently our transforms, but to sort of allude to some other nice things that our data flows can do, and that's firstly is perhaps, as I kind of alluded to there, was loading a data warehouse. Within our mapping data flow, we can, if we wish, define a staging area. And what that staging area will do for us if we are going into a SQL DW or a Synapse data warehouse destination is it will do the hard work for us when it comes to defining our external tables and our external data sources, which means when we load that data warehouse, it can use Polybase, it can parallelize, and it can do that work for us very easily. If you don't know what Polybase is, you don't have to worry about it. The mapping data flow is going to take care of that work for you, and it's going to load that data warehouse as quickly as it can. The next thing that I want to tell you about within our mapping data flow is the partition handling. So we don't have to do any work here again. We can define it using the graphical interface via Data Factory, we can optimize, spelt wrong, but we can optimize our transforms. We can also broadcast data in our joins if we want. So that graphical ability to do that is very nice. We can, if we want, within our mapping data flow, enable debug mode. Once we do that, we can preview our data at the point of building that transform. So if you're definitely a sys package developer, you might be used to doing maybe a multicast or something and getting a data viewer up there while you're debugging to see what's happened in your transform. Within Data Factory, we enable that debug mode, it warms up that Spark cluster for us, and we can see those data movements, those transforms as we go through. So very nice. So that's our mapping data flow. And those are kind of a few nice things that I like to call out. If we now turn our attention to our wrangling data flow, and I've kind of got the same sort of picture here. We've got that control flow plane at the top. And here is the visual of what our wrangling data flow looks like. And like with our mapping data flow, this gets converted to data flow Spark. But you're probably squinting and looking at my slide and thinking, I recognize that UI. I know what that wrangling data flow looks like. And you absolutely would be correct. It looks very much like what we had within Power Query, within Power BI, using Power Query. And absolutely, this is very much one and the same, if you like. What we get with our Power Query capability from Power BI is hopefully at some point in the future, what we will have available to us in our wrangling data flow. Wrangling data flows are still in preview in Data Factory, but hopefully you now understand as where we could take our Power Query content and we could mature it perhaps into our wrangling data flows within Data Factory. So that's what our wrangling data flows can do. Now, the last thing I'll touch on when it comes to data flows is configuring that Spark cluster, because we have to define that compute somewhere. We talked about it in our SSIS IR, how we define those clusters. How are we going to define this Spark compute for our data flows? And very deliberately in my slide here, the way we do that is using the Azure Integration Runtime. So because data flows are kind of an internal activity, if you like, to Data Factory, the Spark compute, the number of driver nodes, number of worker nodes that we have for that cluster, it gets defined in that Azure IR. We say what's the compute type, the worker nodes, the time to live. And when we deploy or we specify a new Azure IR, we can set those things if we wish to use them. The default Azure IR that you get within your Data Factory will have one of these. It will have a general purpose compute cluster, and it will have 4 workers, and it'll have no time to live, basically. So just bear that in mind, that it's at the Azure IR level that these things can happen. Okay, so let's move on. And now let's just think about data transformation in its broadest sense, because I've introduced to you these 2 data flow capabilities of our Data Factory. How does that really sort of translate? And you might be thinking, well, there's all these other things that I could use within Azure to transform my data. Yes, absolutely. I've put a few contentious ones on here quite deliberately. Hopefully you can gather that Cosmos isn't the right place to transform your data, but you could do. But there's all these other things. So what I'll do is perhaps just to try and summarize our Data Factory data flows is change the question and say, well, when should we use Data Factory data flows? No, I'm not here to tell you exactly when you should use them. I just obviously want to kind of allude to perhaps where or why. And the first way to try and answer that question is with this very simple table, that if we want to make the argument for scaling up or scaling out our compute and using that cloud native capability, then there's some definite conditions there we need to consider. Also, if we then couple that with the fact that we have this very rich developer UI that we can take advantage of, then that's really where we kind of get all of those ticks. Our data flows within Data Factory, we can build them in that graphical, low code, no code type setup. We can scale out the compute using that Spark distributed cluster. We can scale those worker nodes up if we wish. And of course, it is using that cloud native tech. Don't confuse that scaling out with distributing SSIS packages over a cluster. We're now talking about distributing the compute at the row level, at the transformation level. So that's one way perhaps to answer that, when should I use them? Then perhaps the other use cases or the things that I've encountered so far for our Data Factory data flows is those SIS package developers that are out there. You know, if you feel that you want to transfer your skills into Azure, mapping data flows are perfect for you. You know, the things you've been doing in SIS packages at the data flow level, you know, they can easily migrate your knowledge there to using a mapping data flow within Data Factory. Data engineers perhaps that are using Power Query within Power BI, maybe to do a POC or to do something with the Power Query expressions in M or whatever, you know, you can absolutely at some point in the future copy and paste that Power Query from Power BI up into Data Factory, wrangling data flows if you wish. The feature parity, it's not quite there yet, but hopefully at some point in the future, those will be sort of one and the same capability. As I kind of alluded to in my slides, when it comes to loading a data warehouse or doing some rapid prototyping, a mapping data flow is a really nice way to quickly do that, to connect things together in that UI, load that warehouse, all good. And then my last use case is perhaps for maybe the data scientist. I kind of get mixed responses to this one, but I don't want data scientists to be spending all of their time getting that data set in the right format, you know, getting all those attributes they need in the right shape. I want that to be done really quickly and easily. And then of course they can do the fun predictive stuff, which is what they're good at. So what I'll say is that maybe those mapping data flows, there's a use case there for the data scientist to quickly get that data set in the right place, in the right format, using all of those Azure Data Factory connectors. Then they can land it in the lake and do whatever they want to do next. So to answer that question of when should I use these Data Factory data flows, a few arguments there. They're not strong arguments, but you know, there's lots of ways to do things. Many ways to skin the cat, perhaps, would be the saying. Obviously, not a very cat-friendly saying, but those are the use cases that we have for now. So let's move on then. Let's change gears again. So far I've talked about all of the more sort of developer-y things, the things that we're going to build within our data factory. Now let's kind of turn our attention to the source control, the deployment, maybe the production of our data factory resources and the things that we now actually need to do. So if I draw your attention to this visual for now, and what we can say is that actually within our data factory as a developer, as you saw me do in my demo, we go to the Azure UI. We have perhaps our data factory connected to a Git repository, either via Azure DevOps or via GitHub. And we can debug those pipelines we build. And we can have that, as I've kind of put in the slide here, that debug service. We can also, if we wish, using that one data factory, publish those components. And we can have that deployed sets of information, that deployed Azure data factory. And the way to kind of make that distinction is that we could say that if we're SIS package developers, we have Visual Studio, we have that debug, that developer environment, and we hit deploy or whatever, and those SIS packages go to our SQL Server Integration Services server. Now, within our data factory, we get both of those things married together within that browser environment. So if you are connected to Git and you've got that debug service, when you hit publish, it is like taking that content and deploying it. So we could, if we want, make that distinction between our dev and our prod environments all within one data factory, if we wanted to. But this is a problem, and that is when it comes to getting our data factory source code. And you think, well, why is that a problem, Paul? Well, what you'll find is that when you connect Data Factory to your Git repo, you will get these artifacts created in there for your different link services. You'll get subfolders in that repo and a JSON file for each part of your data factory. So that's one set of potential source artifacts you could have. You can, via the developer UI, also download an ARM template. From the toolbar, you can download that JSON file, you can get an export of that, so you then get another set of artifacts, if you like, in an ARM template format this time, not individual files, all wrapped up together as a single JSON artifact. Then you think, okay, if you were to use that publish button, and if we're going to be good developers and say we have multiple data factory environments, so that's not going to be prod, that's just really development. But if you hit publish, what Data Factory does behind the scenes, and this is where it gets even more confusing, is it will create another branch against your repository. And what you'll find in that branch, which is called ADF_publish, you'll find a third set of artifacts. You'll find one that is called ARM template for factory. Now, I said at the top of my slide here, getting our data factory source code, and this is why it can be confusing. But if we're actually thinking about having multiple environments and deploying our data factory, it's that third artifact, that third ARM template for factory.json that we need to use. So let's take that and let's just think about deploying our data factory now. We can, if we wish, use our Azure DevOps tool. We can build those artifacts using some sort of branching strategy if we want, and we can trigger it, or however you want to do that. And when we do that, we get that artifact, that ARM template for factory that we need. We then have a release pipeline if you want, or some YAML, I don't mind. I would use a release pipeline because it's easy and it's nice. We have a pipeline to deploy to test. We use a task to do an ARM resource deployment. Maybe we give it some parameters for the name of our factory and things, and we trigger it and we get our test data factory. We clone our pipeline, we go again, maybe we have some approval gateways, and then we get our production data factory. So, that's how we could, in theory, deploy our data factory using that ARM template. But just bear in mind that if you do that, those 5 parts of our data factory that I talked about in the beginning, that ARM template is only going to, out of the box, parameterize the link services. If you've got other pipeline parameters and other things that you want within there that you want to change between your deployments, that's not going to happen, okay? So just be careful of that this is one approach to deploying your data factory. It's the approach that Microsoft would recommend, but it's not necessarily the most flexible or the best way to do it, okay? So let's now turn our attention to monitoring and logging.
Paul,
now,
have you looked at the watch?
Yes, I've still got 15 minutes, right?
No. The next session is on in 15 minutes.
Okay, I thought it was an hour and a half session.
No, it's 60 plus minutes. But the next one is at 12:30 UTC. So yeah, in 15.
Okay, sorry, maybe the calendar invite I had was an hour and a half, but okay.
We'll blame Daniel.
Okay. What I'll do then, monitoring a login is not very interesting anyway. I will just jump straight to our conclusions then and wrap up. And what I'll do is in a couple of slides very quickly, I'll say, well, let's draw some conclusions then. And I'll come back to this one where we started and say, what is Azure Data Factory? Now, I phrased it as this orchestrator, this conductor in the beginning, but let's kind of go a little deeper now. Let's think about Data Factory in terms of what we now know, given what I've talked to you about. And that is perhaps more of a richer picture of all of those activities, that control flow and that data flow capability. So we can maybe answer the question by saying Data Factory is the orchestrator of our control flow operations and our data flow operations. It is going to be the scheduler perhaps of our solution, and it absolutely is that integration tool, that complete integration tool now for all our needs. So hopefully that's a better answer given what we now know about our Data Factory. And second to last slide, people say to me, okay, what next? If you are perhaps a fan of this, you want to look into this more, the thing that I would steer you towards next is a blog post that I've created and do update quite regularly, and that is the best practices for implementing Data Factory. So currently there's 24 points on there of things that you need to consider, some of which I've covered, some of which obviously there's a bit more depth there, but some of the things to take away and bear in mind. And that is it from me, folks. Thank you very much for listening. Apologies if I got the timings wrong there slightly. As mentioned at the beginning, the slides are available in my community events repo. And if you like some of the visuals that I included in my slides, feel free to go and get a Visio stencil of those Azure icons as well from my community, from my content collateral repository. Thank you very much.
Awesome. Thank you so much for this. The Data Factory is something that I've been looking at like from the corner of my eye, and hearing you and Camille and Katrina talk about it, well, I decided that, yeah, I want to see this. So now I'm an expert.
Well, yeah,
So
there's so much more other stuff I could talk about and lots of other depth and things to go into, but hopefully, yeah, it's a good flavor.
And the thing is, working with these things, you know for a fact that you will never, ever be bored, because if you turn your back or, God forbid, go on vacation, half of it is going to change anyways.
Yeah, sure. Yeah. I don't think I've ever managed to reuse a slide deck yet in my talks because it's always out of date or something's always changed.
Yeah, they have a pretty short half-life.
Yeah, absolutely.
Okay, so the next speaker is going to be Nikola Illich, and I see he's here. He is muted.
I'm here, Alexander. Hi.